Welcome to Displaying Data. A couple of these early slides are a revision of what we did in Year 11 as part of the preliminary HSC course. So we'll just go quickly over some of this information. So when you're collecting data, it can be from a primary or a secondary source. You might have learnt that in other subjects. A census is when you ask everyone, and a sample is a proportion of that population. You've got the four types of sampling. So you've got random, so that's like names in a hat or lotto numbers. Stratified, that's categories or strata of the population chosen from the members of each category. So you might choose one student from each year at your school. Systematic, members of the population are chosen regular intervals. So every 10th would be a good example. Production line is a good example of systematic. They don't sample every single item that comes off the production line. They do every 10th or 100th. And self-selected, that's where you get the chance to volunteer yourself. Classification of data, you've got categorical, also known as qualitative. That's representing data that can be divided into groups. So gender is a good example, place of birth, favorite color, and you have nominal where there's no order or ordinal where there is an order. Numerical is quantitative, and that's where the data can be counted. So numbers are normally a good example, so how many children, and you can divide into two groups. Discrete, where they're exact, or continuous can take any numerical value. So that's multiples of decimals. This is an example of a frequency table and a cumulative frequency table. So the frequency just shows how many of each occur, and cumulative frequency means that you add up the frequencies as you go. So the measures of central tendency, these measure the center or middle of the data. So we've got the mean, the median, and the mode are examples of those. Measures of spread give us an idea how far this data is spread from the center. So range is the 100% of the data, so that's highest minus lowest. Interquartile range is the middle 50%, so that's quartile 3 minus quartile 1. And variance and standard deviation measure how spread the data is from the mean. Interquartile range and standard deviation and variance we will do in a future video. So this is a new type of chart. It's called a Pareto chart, not normally introduced in the in 7 to 10. So what we do with it is it helps us to display categorical data. A lot of businesses and industries use this to allow them to focus on overall improvement. So even government, local governments would use this, especially if they're trying to identify crime in the local area. They would look at a Pareto chart. So for example, 80% of the consequences come from 20% of the causes. That's what a Pareto chart looks at. So 2002, Microsoft did an actual survey, and they worked out that 80% of the errors and crashes in Microsoft in the Windows and Office were caused by 20% of the entire pool of the bugs detected. So therefore, they could focus on those 20% of the bugs. They could fix nearly all of their problems. An example in real life for yourselves would be that they say that 20% of your clothes you actually wear 80% of the time. And if you think about that, that's probably the reality. So that means that the other 80% of your clothes get worn very little, so 20% of the time, and probably just sit in your cupboard. So when you draw Pareto charts, you take those categories and you arrange in order from in descending order. So that places the most serious concern first. Then you complete a cumulative frequency column, followed by a cumulative percentage column, and then the graph has two sides. The left-hand side is labeled the frequency histogram side, and the right-hand side is labeled the cumulative percentage polygon. So this is an example. So we're looking at a software company. They want to analyze the top reasons contributing to defect codes. So you've got a list there, the frequencies, and since it's out of 103, the total frequencies, you can work out the percentages. Next, you rearrange them. So as we said before, you rearrange them in descending order. So highest frequency first, down to the lowest frequency. And that also obviously puts the percentages in the order from highest to lowest. Create a cumulative percentage. So remember, cumulative is to add up all of the percentages as you go, or to add up as you go. So the first percentage is 44%. When you add 26 to it, you get 70%. Add 17, you get 87%. Add 12, you get 99%. And finally, add 1%, you get 100%. Creating the frequency histogram on the left-hand side and the cumulative frequency percentage on the other side, you can see that that's our Pareto chart. And you can see the 80% mark shows that those first two actually fall into that. So if they were to focus on not following code standards and lack of expertise, they would actually solve most of their problems. The final one way we're going to look at displaying data is two-way tables. So it investigates two variables that are related. So in this example, we're looking at students were asked whether they like or dislike tofu, and they're the results. So 100 students were asked. And the questions can be sometimes a little bit tricky. Sometimes you've got to focus on what the actual what you've narrowed down. So the first one is, what percentage of the students like tofu? So of all the students, how many actually like tofu? And that's 65 out of 100, as you can see. So that's 65 out of 100 actually like tofu. For the second one, this is like conditional probability. So given that the student is female, so that's a conditional probability. So given that they were female, what percentage like tofu? So out of the females, how many like tofu? So that is 30 out of 44, that is 68%. Thank you.